Welcome back to Python programming from beginner to programmer. In this video segment, we'll learn about how to use Python to drive SQL and issue select statements to read or retrieve back data from the database. So let's move over to the classroom slide. And in this slide, we see we can issue the select statement that we have already learned in the previous video segments. Basically, in this particular video segment, we want to see how we can embed this into the Python script so that we can use Python script to drive SQL database. Now, the colored blocks here should remind us that whenever we need to interface with SQL, it's always in this order. These three blocks are always in this order. The yellow block to import and connect to the database in order to establish a connection object, right? And the final block is the white color block to close off the cursor and then the connection. And in the middle will be one or more green blocks where you have cursor and then you execute the SQL statement or statements, and then you either perform reading or writing data, right, to and from the database. So basically these three steps, and all kinds of SQL commands follow these three steps. So in this video segment, we want to learn about selecting because it is reading back data, and you might have situations where you have a lot of rows of data, a lot of records of data that are being retrieved. So for example, in this situation, we're trying to retrieve from the accounts database all the subtypes which contain the word, exactly the word expense. So all the accounts that are expense related. How do we go about that? Very simple. We know the SQL command is just select star everything, all the columns from, right? So selecting is always reading back rows, and select which column is listed out in this list of comma separated list of column names. And if we want everything, because we don't know the column names, then we just put star there. So the key is to run the cursor's method called fetch all. All right, so as simple as that, we just fetch all. And I think we have seen a couple of examples earlier on where we just sort of quickly talk over it. But just to quickly get back the data, and that's for learning other stuff. But here we are really examining this method, this function, cursor dot fetch all. Now remember, it's cursor. Everything is done through cursor. All right, and we don't use the connection, but cursor knows about the connection because it was derived from connection itself. And I put all rows here to remind ourselves that since each row is kind of naturally reflected as a list in Python, then all rows would be a list of all the lists, right? And indeed it is. So when we print all rows, we would see a list of tuples. But the reason why it's tuple is that SQL is very specific, particular about the integrity of the data. And of course, rightfully so, because it's database, right? Who else to secure and guard our data than this, specialist called database? So the idea is that no one should be able to change the data in each record, like altering your name, changing your bank account number, changing the account code, and all that, right? So that's the idea. And the way to convey this idea in Python is very easy. Just call it a tuple, and Python will enforce the read-only property of this record. So that's nice, and therefore it makes sense to return a tuple than a list, as if database is signifying that you may change this data and I will update it automatically, right? No, no such thing. So the fetch all returns list of all rows, and then we print a line, which you see here, right? And then we say fetching all balance sheet accounts. Something nice, right? Because that's our business goal. We say we want all the balance sheet accounts, and that's reflected in FR type being equal to BS here. Yeah. So we know how to issue the SQL select command. And this time around, we name the columns that we want. So name, account code, and not, because we don't need to see FR type. It will have to be equal to BS, right? So we can drop that. You can drop the subtype. maybe because at this point we are not interested. So we fetch all, and this time round we have again the list of all tuples, right? All rows, and we can, instead of printing all, as if we don't have the ability to inspect and process each row, we can actually just do a for row in fetch all. And this is actually encouraged, because when we do this, the for will partner with, right, will work together with this fetch all method, to put it simply, in such a way that fetch all will not sort of in one go uh, bring in the whole 5 GB of data, or 5 million rows, before for loop starts to run. What it does is that for will say, okay, fetch all, give me the next row. Now row has the next row, and then you run the code, name code row print out. So you will see the rows printing out kind of maybe slowly, but definitely progressing. Rather than you wait hanging there for 5,000 rows to be read in, then all of a sudden all the rows come out, right? So uh, the previous way, the Python's way, is that it will kind of do a progressive iteration of the for loop. And that's nice. That's often, in many programming circumstances, much preferred, because even for user, you prefer to see that your picture is kind of loading little bit, rather than blank screen, wait, and then all of a sudden the picture comes out, right? I mean, in both cases, we might have waited in total 5 seconds. Still, the experience is much better if we can see the picture in progress than to wait for 4.9 seconds and then the 0.1 second flash out the full image. So same thing goes here. If we have 5,000 rows, then we would prefer that each row be fetched in, processed, and then we see the printing out of the name and code. As each row is being fetched in, we get processed, and then move on to the next row, iterate to the next row, and so on and so forth. So this form is actually the preferred way to step through and process each row. Now, obviously, if you want to skip a row, then it will be a bit troublesome, because you better remember that skipped row in memory if you should need it in future, because otherwise you have to fetch again, right? Re-execute again and fetch back again. So every time we touch the SQL via cursor.execute many, or cursor.execute script, these three commands only. Every time we do that, think of it as a slow, slow is relative, but think of it as a slow function call. Okay, so slow is relative to processing within memory, assigning to variables, operating on data frames, pandas, that's fully within memory. That's much faster. When I say much faster, it can be 1,000 times faster than to retrieve from database. Now, of course, if you're working in nanoseconds, 1,000 times faster is still microseconds, and it's hardly perceivable by human beings. But when you multiply by, that difference, that 1,000 times difference, to 5 million records, you begin to feel the drag, right? All the slow code logic has on the total timings. So definitely consider, doing as few execute as necessary. So this is not supposed to teach you to try to be stingy about accessing SQL. You still do what you need to do, but sometimes if you didn't sort of plan your code well, or organize your loops and function calls properly, you will end up duplicating the effort, or retrieving a lot of rows that you end up not wanting, like just throwing away, and therefore wasting the computer time, right? So do keep in mind about those. So let's move over to our Python, our SQLite Studio and Spider. So this was left over from previous demos. Now, at the start of this discussion, we started a script called SQL create DB, right? Just to make sure that every time we are stuck or modified our accounts.db, we can easily reset it, delete everything, and restart all over. So this is the one. and I've saved it. This was created in several video segments back. So I've saved this into SQL create db.py. Okay, so we will drop it and recreate everything and so on in the commit. So let's look at our SQLite Studio. The remaining rows after our delete SQL command, right, demonstration, this is what is left, 8 rows. So we won't be really getting the results that we see in the classroom slide. So what we can do is we can run this. Okay, so let's run this and see. Okay, so we managed to fetch back everything, including salary and no entertainment, right? The row of entertainment isn't there anymore. So over here, while SQLite Studio is still having a connection to the same database. So SQLite has a connection to the database, and at one point, our Python script also has connection to the same database, the same file. You realize that if you force delete it, if you try to delete, remove using File Explorer, Windows Explorer, you realize that you cannot delete because the file is being connected. But strangely, our Python script, which is another application, can connect to it and modify it and delete everything and then drop the table some more and then recreate the table and populate the table. So that is why database is so useful in the sense that you are not being sort of held back by the file access issues that the operating system imposes, right? So if one application, SQLite Studio, opens the file, then other applications are not able to open the file. So SQLite, so database actually allows us to have parallel modifications or read and write in a way that is going to still maintain the database integrity. So let's do a refresh. And great, we see the sort of reinitialization of the data, initial data. And now we are back in game, right? So we will create a new script. And what we need is simply to maybe just copy from our previous scripts because the 3 blocks are there. The yellow block, right? Of course, I inserted the change directory to make sure that I'm operating on the same account.db that we have been creating. So then we create this cursor, derive this cursor, and we would like to update the command to select star from account where subtype equal to expense. Now, because this is a one-liner, we can also actually put this right inside to make it look exactly like the classroom screen. Okay, so then we can do this, right? Then we have all rows, right? All, no, execute this command. All rows equals to cursor.fetch all, and that's it. Okay, so one function call, fetch all. Inside, it will iterate through. It will have a for or nested for if necessary to bring in everything, all the rows and all the columns. Well, all the columns as specified here in the select statement. All right. And then what we do is we'll print all rows and then we print a separator. Okay. And we don't need commit because basically we're just reading, we're not modifying. So it's